Look up at the night sky, see those countless stars. Among them, our Earth is a tiny, precious jewel. It is a vibrant blue marble teeming with life. This is our only home in the vast cosmic ocean. We have a profound duty to protect it. Its delicate balance is now under threat. Climate change, pollution, and loss of biodiversity are serious challenges. We must act now with wisdom and care. Our planet needs our help, urgently. The future of Earth depends on our choices today. We need sustainable practices. We need to live in harmony with nature. Think of a world powered by clean energy. Imagine cities where waste is minimal. Picture forests thriving and oceans clean. This dream requires innovation. It demands new ways of thinking. Technology can be a powerful ally in this quest. Enter the realm of technological intelligence. This is where human ingenuity meets the power of machines. We are developing tools that can learn. These tools can adapt and help us solve complex problems. What exactly is machine learning, you might ask? Imagine teaching a child to recognize a cat. You show them many pictures of cats. They learn the features: pointy ears, whiskers, a tail. Machine learning, or ML, works in a similar way. It is a type of artificial intelligence. It allows computers to learn from data. They learn without being explicitly programmed for every single task. This is a big step for computers. Think of it as a computer brain. This brain can observe patterns. It can make predictions. It can improve its performance over time. All this happens by feeding it information, lots of information. This information is called data. The more data it sees, the better it often becomes. It's like us learning from experience. ML algorithms are the methods, the recipes that enable this learning. They are the engines of this intelligence. Machine learning is a branch of artificial intelligence. AI is the broader concept. It is about creating machines that can perform tasks that typically require human intelligence. ML is a specific way to achieve AI. Let's explore the types of machine learning. The first one is called supervised learning. Imagine you are a student in a classroom. You have a teacher guiding you. The teacher gives you questions. The teacher also gives you the correct answers. You learn by comparing your answers to the correct ones. This is how supervised learning works. The machine learns from labeled data. This data has both inputs and their corresponding correct outputs. Consider sorting your emails. Some are important, some are spam. In supervised learning, we would feed the machine many emails. Each email would be labeled spam or not spam. The machine, the algorithm, learns the patterns. It learns what makes an email spam. Maybe certain words appear often, or the sender's address looks suspicious. After learning, it can predict if a new unseen email is spam. This is very useful. Another example is predicting house prices. We give the machine data about houses. This includes size, number of bedrooms, location. Crucially, it also includes their actual selling prices. These prices are the labels. The machine learns the relationship. Now let's journey to unsupervised learning. Imagine exploring a new, uncharted planet. There are no maps, no guides. You must observe everything yourself. You look for patterns. You group similar-looking rocks together. You identify strange, unique formations. This is the essence of unsupervised learning. The machine gets data without any labels. It has to find the structure and patterns on its own. There is no teacher providing correct answers. Think about a large group of customers. A business might want to understand them better. Unsupervised learning can help. It can group customers based on their purchasing habits or their browsing history. These groups or segments are not predefined. The algorithm discovers them. This helps businesses tailor their services. They can offer more relevant products. This is called clustering. It is a common unsupervised learning task. Another application is anomaly detection. Imagine monitoring a complex system, perhaps a power grid or a natural ecosystem. Unsupervised learning can identify unusual behavior. It can spot data points that are very different from the rest. These could be signs of a fault. Section 5. Reinforcement learning, trial, error, and stellar rewards. Our next stop is reinforcement learning. This is like teaching a dog a new trick. You don't show it labeled examples. Instead, the dog tries different actions. If it does something right, you give it a treat, a reward. If it does something wrong, perhaps no treat, a penalty. Over time, the dog learns which actions lead to rewards. Reinforcement learning, or RL, works on this principle of rewards and punishments. The machine learns by interacting with an environment. Consider a robot learning to walk. It tries various movements. If a movement helps it stay balanced and move forward, it gets a positive reward. If it falls, it gets a negative reward or a penalty. The robot's goal is to maximize its total reward over time. It learns a policy. A policy is a strategy for choosing actions. It learns what to do in different situations. This is a continuous learning process. Through trial and error, it improves. Reinforcement learning is powerful for complex decision-making tasks. Think about self-driving cars. They need to make many decisions constantly. When to accelerate, when to brake, when to turn. RL can help train these systems. The car drives in a simulated environment. Section 6. The ML Toolkit, Understanding Data, Models and Pitfalls. To build with machine learning, we need some key tools and concepts. First, datasets. Data is the fuel for ML. A dataset is a collection of data. It could be numbers, text, images, or sounds. The quality and quantity of data are crucial. Good data leads to good models. Bad data, or garbage in, leads to garbage out. So preparing and cleaning data is a very important step. It is often the most time-consuming part. Next, we have training versus testing. Imagine studying for an exam. You use textbooks and practice questions to learn. This is like the training phase in ML. We use a part of our data set, the training data, to teach the model. Then, the exam itself uses new questions you haven't seen before. This is the testing phase. We use a separate part of the data set, the test data, to evaluate the model. This tells us how well it will perform on new unseen data. Algorithms are the heart of ML. An algorithm is a set of rules or instructions. It tells the computer how to learn from the data. There are many different algorithms. Each is suited for different types of problems. For example, decision trees, support vector machines, or neural networks. Choosing the right algorithm is important. Section 7. Machine learning in our world, seeds of a greener tomorrow. Machine learning is not just a theory. It is already changing our world. It is making our daily lives easier in many ways. Think of recommendation systems. On shopping sites or streaming services, they learn your preferences. They suggest products or movies you might like. Spam filters in your email use ML. Virtual assistants on your phone understand your voice commands, all thanks to machine learning. These are just a few examples, but the real excitement for our planet lies elsewhere. ML can be a powerful force for environmental conservation. Consider precision agriculture. ML algorithms can analyze data from sensors. Data about soil, weather, and crop health. This helps farmers use water and fertilizers more efficiently. It reduces waste and environmental impact. It can also predict crop yields. This helps in planning food security. Smart farming for a sustainable future. ML is also helping us protect wildlife. Algorithms can analyze images from camera traps or sounds from acoustic sensors. They can identify and count animals. They can track endangered species. They can even detect poaching activities. This provides valuable data for conservationists. Section 8. Embarking on your ML voyage, tools, ethics and green AI. Feeling inspired to learn machine learning? That is wonderful. Starting your journey is more accessible than you might think. Many resources are available. Online courses on platforms like Coursera, EDX or Khan Academy offer great introductions. Many are free. You can learn at your own pace. There are also countless tutorials and blogs. The key is to start with the basics. Understand the core concepts first. You will need some tools. Python is a very popular programming language for ML. It has excellent libraries like scikit-learn, TensorFlow and PyTorch. These libraries provide pre-built functions for many ML tasks. This makes it easier to get started. You don't have to build everything from scratch. Start with simple projects, for example, classifying images or predicting simple trends. Hands-on practice is the best way to learn. Don't be afraid to experiment. As you learn, it is vital to consider ethical AI. Machine learning models learn from data. If the data is biased, the model can also become biased. Section 9, your cosmic role building a smarter, greener universe. We have journeyed through the basics of machine learning. We have seen its potential to understand our world, its potential to solve some of our biggest challenges, especially the challenge of building a sustainable future, a future where humanity and nature thrive together. This technology is not just for experts. It is a tool that can empower everyone. You have a role to play in this cosmic endeavor. Think of the Earth as a complex, interconnected system, like a vast, intricate machine, or perhaps a living organism. Machine learning can help us understand its rhythms, its delicate balances. It can help us become better caretakers of this planet. Whether you are a student, a professional, or just a curious mind, you can contribute. By learning, by advocating, by innovating, every small step counts. The path ahead requires both intelligence and wisdom. Intelligence to develop these powerful tools, wisdom to use them responsibly and ethically for the benefit of all life on Earth. Let us be guided by a sense of wonder, wonder for the beauty of our planet.